Hello, everybody. Welcome. My name is Giuseppe from the IoTeX team. Today, we have a pretty cool episode. Today, we're going to talk about DePIN verification. I am joined on stage, as usual, by Simone from our team, and then by Zoe and Wenfeng from the Phala network team. So I'm going to add these people on stage. I'm going to let them introduce themselves and actually introduce the problem that we're going to talk about today, which is DePIN verification. And it's a pretty hot topic in the space. So I would like our guests to talk a little bit about that and see how this can be tackled. So let me just start introducing these people. Hey, guys, how's it going?
Hello.
Hello from Berlin. Nice to be here.
Awesome. Oh, yeah, we're all around the world, right? So Zoe's in Berlin, Simone is in Italy, I'm in New York, and Wenfeng, you are?
China.
In China. Okay, so exactly. So perfect. We cover all the time zones. Sweet. Let's just go around, introduce ourselves, and then we get it rolling. What do you guys think? All right. I guess we start with our guest Simone, since maybe the people that watch these already kind of know a little bit about us. So I would start with Zoe, maybe.
Thank you so much. Hello, everyone. Great to be here. Our first live stream with our great partner, IoTeX. I'm Zoe, VP of Growth at Phala Network. Answering or commenting on all this deep technical topic today from a high-level perspective, but I'm very excited to be here because I'm leading the partnership with IoTeX. I hope that we can, myself and Wenfeng, can bring some clarification and educational insights about the verification on DePIN. Thank you.
Awesome. Thank you. Thanks for being here, Zoe. And yeah, we're super excited because there is a lot of interesting angles that together we can take to tackle this DePIN verification. But obviously, before we talk about the solutions, we'll talk a little bit about the problem, maybe for those who are not familiar. But before we do that, let's go for an intro from Wenfeng.
Yeah, hello guys. I'm Wenfeng from Phala Network. I'm a builder and researcher. And recently, I'm more like a tea evangelist. Yeah.
Tea evangelist. That's a pretty cool title. I think if you go to your settings, you can add it right now next to Phala. You can do tea evangelist. It'd be cool.
Yeah.
Sweet. And I guess the man that needs no introduction, Simone. I mean, muted. You still need no introduction, but you know.
Sorry. So yeah, hi everyone. Simone here, leading developer relations at IoTeX, and yeah, looking forward to these great discussions today.
Sweet, awesome. I like when we do short introductions. In the past, we've had some very long rounds of introductions from people that basically ended up taking like presentations. So I guess when we keep it nice and sweet. Awesome. Okay, so introductions are done. I wanted to just maybe go to start talking about this DePIN verification. Maybe we start from like a little bit of a high level, and then we get into like the more specifics. So maybe Simone, just give us a little bit of an introduction on this and the various angles. And
let's set the stage for the discussion. First of all, I want to say that most of the things, if not actually all of the things we are going to talk about, at least on the IoTeX side, can be found into the IoTeX 2.0 white paper. So basically,
I'm going to share the link.
Yeah, you can share the link, and anyway, you can also find it on the documentation portal docs.iotex.io. So if you want to follow along or you have like doubts, just head over to the white paper or the documentation portal and use the search to search any words that seems weird to you. But yeah, overall, there is a great actually paragraph into the IoTeX 2.0 white paper, which is short but very insightful, and it summarizes exactly the problem of DePIN, the DePIN verification problem, right? So basically, in a few words, what is DePIN essentially? It's about transferring the concept of blockchain, so the concept behind incentivizing someone to do some work to that like is used for public utility. That's what's behind the concept of blockchain, right? You are incentivizing miners to provide a service to anyone, and anyone will pay a fee to use this service, which is the blockchain. So DePIN is basically an extension of this concept to the physical world. So can we apply the blockchain concept to the physical world? Can we actually incentivize people or machines to do something into the physical world and reward these people or these machines, assuming that whatever work they're doing is useful to someone else who is willing to pay for it, right? And so this is basically DePIN, what DePIN is. But the problem is exactly how can we prove what has been done in the physical world, right? With blockchain, it's all about software protocol. So you have the consensus. The consensus is running on top of computers. Computers can do something. Other computers can prove it to the rest of the ecosystem and just write it into the immutable ledger. But in the physical world, when you have people and machines, how can you actually prove what has been done? And that's actually the verification, the DePIN verification problem. So let's take one obvious or pretty familiar example of a DePIN application, which is, for example, a decentralized Wi-Fi network, or right? So you have some nodes into this infrastructure that are deployed in the physical world. These nodes promise that they will, these are routers, right? So these routers promise that they will provide internet connectivity to other people who want to pay for it, right? And then the owner of the router should be rewarded for providing this service. So how can you prove that these routers did actually do what they're supposed to do? And for how long? And with what level of quality, for example, right? How do you prove it? So this is before you trigger any token economy. So this is the DePIN verification problem. There are, first of all, this has not been solved, right? Let's be clear. DePIN is an emerging field, and we are all researching this field. It's been solved for some use cases. It's not solved for any use case. There are different approaches to solve the DePIN problem. One is, for example, to solve it on the hardware side. So using some secure elements or TEs on the device to anchor it to the device identity on chain, and so that you can more easily, securely identify the device. And then this identity can also be used to, for example, to sign or to authenticate the device before it sends out data, and so that you can also identify the data provenance, right? This is one possible solution. But then you have the problem how you process this data before you extract any insight or any any proof of something, and you're going to do this out of the blockchain. So you still have to prove this computation to the blockchain. Right? How can you make sure that even if the data and the device were valid, how can you ensure that the computation is valid before you prove something? And so validity proofs are another possible solution to this other aspect of DePIN verification. Another possible solution that has been researched is the statistical solution, where, for example, you have another network or part of your DePIN network that has nodes that are specialized to verify what's happening, right? How the actual nodes of the network are behaving. For example, they could query these nodes or ask for the service to this node, but it's kind of a dummy request, only to prove that they are actually providing that service and that the quality is good. And this is another possible approach to make sure that the nodes are what they say they are, who they say they are, and they are actually providing the service that they say they are providing. And this is another approach, right? And so no one of these approaches has solved the problem, but they can be used together, right, to solve the DePIN verification problem. At IoTeX, we've been working a lot on those who have been part of the IoTeX community for long. They know we have worked on hardware, so with Pebble Tracker, with UCAM. So we have worked a lot on how to design hardware to make it trusted, how to make it generate data that is trusted, that can be used for Web3 applications. And we are also working now with IoTeX 2.0 on releasing WebStream, which is another infrastructure that gives you the ability to approach the problem from the data processing, the like verifiable data processing way. And so during this live stream, we are going to focus on this part of the solution. So how to solve the data computation in a verifiable way, so that the blockchain token economy can actually trust and verify what happened in the physical world, and then trigger some token economy. And within like this part of the DePIN verification solution, also, of course, the ZK has a role here, multi-party computation has a role, but also TEE and trusted execution environments have a role. So yeah, I guess we're going to talk basically about this part, verifiable computation and WebStream, and how TEE or the Phala solution for TEE, for a TEE network, can help like powering DePIN applications that want to solve the verification problem.
Yeah, totally agree. And I mean, the reason is that we're going to focus on the computation part. I don't know, maybe you said it earlier, but it's because when thinking about maybe new DePIN networks spawning out, or maybe new DePIN solution coming out, is a little bit hard or less feasible to assume that everybody's going to come up with their own devices or build devices from scratch that already have like a trusted hardware that's sending data to these DePIN networks. So a lot of the solutions that we're seeing nowadays are based already on existing hardware, or maybe on existing devices that people use in their everyday, like their phones or their laptops. And so I think solving the computational part of the issue is a little bit more practical in terms of general use cases in the DePIN sector. So yeah, cool. I think Zoe, you had shared this link about basically something that you had posted from the Phala blog, I'm guessing, about what is DePIN. I think it's pretty cool. So I don't know, maybe if some in the audience is new, it's always good to have like a little bit of a refresher. So we'll talk about verification. Maybe it's like we take a half step back, talk a little bit about DePIN in general, and how you guys fit in the space, and then we will transition to maybe Wenfeng talking about. I mean, first, talk about Phala, and then we'll transition into Wenfeng talking about the TE particularly. And in the meantime, I will share the link for what is DePIN.
Thank you so much. Yeah, I just wanted to add to what Simone said, or Luca, you just mentioned that. I mean, DePIN is a lot of people also say every blockchain kind of is a DePIN, right? But of course, there are big differences, and IoTeX is definitely a leader in the space, I would say. And now other people like Phala come in to explain why or what we are providing specifically within DePIN, right? So Phala overall is a DePIN coprocessor, focusing on providing this coprocessor network for AI. We are not touching too much on the AI topic today. This is more like the application level that can be run on top of Phala network. However, we are focusing more on the core infrastructure, right? The DePIN coprocessor. And why we say coprocessor is because we have our own blockchain, and we offload most of the heavy computation, the CPU power, off-chain, which is then secured by trusted execution environments. And Simone gave a good introduction on high level why this verification is needed within DePIN. And Phala is really the leader in providing the biggest TE-based cloud in Web3. We have over 30,000 TE nodes that are run decentralized and by individuals from the network. We have built this cloud since 2018. And we can proudly say that's really the biggest TE-based cloud. Focusing on the CPU part. And however, this cloud can always be extended and can grow, because we have the specific tokenomics, which is a unique approach to DePIN, right? Why you want to bring your server or your node into the Phala network. Why we use and how we use trusted execution environments is something that Wenfeng will cover. I just wanted to add to the overall DePIN topic, which is also covered in our blog post that we just shared, is that you can also difference or break down DePIN within physical resource networks, in short PRN, and digital resource networks, which is DRN. And just to compare this a little bit, it's about if you provide physical resources on a location based, or you provide digital resources that are independent from the location. And Phala falls more into the DRN, the digital resource networks, which is more highly used into networks that provide storage or compute, or also bandwidth services. So have a look into the blog post. It's described much more in detail there. And I would say that IoTeX definitely covers both areas, because you are also through your Explorer and like for all your services, like more the umbrella for the DePIN, the DePIN services. And Phala focuses more on the digital resource network specifically. I think this is it for the high level intro, and we focus more again on like why we actually need trusted execution environments to provide the best DePIN service.
Sweet, thanks, Zoe. Yeah, when you said blockchains are DePINs, we opened like a can of worms there. It's a super polarizing debate in the space. So I thought that was pretty funny. I think generally, what are you saying?
Sorry, I don't necessarily agree with this. I just wanted to break it down why we talk specifically about DePIN and DePIN verification. Yes, I know it's something that's thrown out often there. But maybe for people that are joining a very early stage or need a better overview, right? This is
I mean, it's food for thought. I can see the arguments for and against. So it's not a given. I think in general terms, kind of like related to what I was saying earlier, digital resource networks are usually associated more with like you were saying, sharing of like maybe computational resources or storage. Usually associated with like existing devices. So maybe people like use their own laptop or their own phone to like contribute to a certain network. While I think in general, just as a high level, the physical resource networks are somewhat associated with devices that maybe, let's say, the end user purchases or acquires to then contribute specifically to the network, which I think is the reason why they're more associated with like geographical, I don't know what, geographically, because then, the device is like in a certain area. Awesome. You were also mentioning our scanner for Deepin, which is becoming, I think, one of the coolest tools out there for anybody that's into Deepin, wants to learn more, maybe participate in some networks, maybe get some alpha on I don't know, whoever is dropping a new token or maybe dropping a new device, etc. So I invite everybody to maybe check out the deepinscan.io, and and behold, Phala is also there. So if you want to check them out, it would be deepinscan.io/Phala network. Now, without further ado, maybe we can have Wenfeng, the TE evangelist himself, talk about TE.
Yes, for sure. Before I get started, let's say Simon already mentioned that the problem exists in the verifiable DePIN sector. I guess, because the DePIN is more like transferring from the IoT network, and when we say IoT network several years ago, we don't mention that we need to verify the data specifically. And for now, because we have blockchain, we have DePIN, we need to verify the data, collect from all of the device, like the sensor, the Wi-Fi device, etc. But when we talk about validity, no matter you validate with like ZK or TE, it's not possible to verify it through the edge network, like the device and the user hold on their home, like So basically, you need to forward the data to a router or a sequencer. So basically, how we make this verifiability more trustless is, I think, is a crucial problem we need to fix first. So that's why we think that we can combine the verifiability technology like ZK and TEE to make it better. So today I first will introduce TEE, because after the ETHCC, everyone is talking about TEE. So I'd like to first show you guys TEE, what it is, and then we can discuss how it can solve the verifiability problem in DePIN, and how we can combine it. Okay.
No objections. I think Wenfeng, you had some slides or something that you wanted to share, right?
Yeah. Let me.
Sweet. Yeah, feel free to pull them up, and then I can get them up here on screen. In the meantime, let's see. Zoe, you had this other link that was the coprocessor on TEE using JavaScript.
Yeah,
maybe I can share while we.
I'm not sure why I can present. Oh yeah, I found it.
This is a lot of great content, because we also discussed, and a lot of this content is described by Wenfeng, how we can enable actually FHE using trusted execution environments. So I think we will touch on this, right? Why TEE is super important to verify ZK or also FHE, and you can read more in the links that just have been shared.
Sweet.
Okay.
Awesome.
Can you see my screen? I'm not sure.
No, I can't see it up here on stage or in the green room.
Not sure why I can't
Do you have the present button?
Yeah, I have.
You can go on share screens, maybe share screen instead of slides.
I can choose, but there's no button show me. Oh yeah, I can now. Sorry.
It's okay, no worries. It's we're live, so it's
fine. Yeah, it's live stream. Always happen.
Okay, here we are.
So first, what the fuck is TEE? I think after ETHCC, everyone is talking about TEE. So what the fuck is TEE? I think a TEE actually is from my perspective, I will, from a computer science perspective, I think it's some hardware and some software combination, and that is a technology at the intersection of hardware and software, and basically it's designed by some dedicated CPU instruction by the chip manufacturer, and to provide the data confidentiality and integrity of the software running inside of the TEE, and it prohibits the access from the hypervisor or even the IoTeX. And also, when we talk about TEE, I think the most concern people have is the security of the TEE, because you need to trust the manufacturer, and of course there are many vulnerability happened before, especially on the SGX. So basically, when we talk about TEE, we have concern, and so first let's start with where it is located. As I mentioned, that TEE actually is some kind of hardware and software technology and combined together. And so from a computer perspective, we have the hardware and we have the software, and we at the very low level we have the peripherals and like the DRAM, like the voice sensor, the micro, and the hard disk, and then we have CPU and to run the program, and we have the OS supervisor to build a platform that can run the application. And the TEE actually here is like the specific hardware primitives and plus some specific software primitives. So it's an intersection technology. And there are a lot of TEs for you to choose, actually. And as for Intel, we have SGX and TDX. So far, as I know, we have Phala secret OCS swaps cycles to use Intel SGX and TDX. Also, we have AMD SUA, which is also used by like many cloud provider like AWS, Google, and so as I know, then Zama and Lead Protocol use AMD SUA to run their MPC nodes. And we also have ARM trusted zone, which you most likely to run the mobile devices or other embedded devices. And many other specific TE, which they may be used, may designed by FPGA or specific hardware, and to optimize for specific area. And when developer choose TE, I think the most thing is if they need to change a single line code, because developer is very lazy, and so that's why the TDX and the AMD SUA became more and more popular, because they are container based, and you just wrap a container to your program and just send it to the TE to run it. And the truth is, there are some trust assumptions exist. So here is the problem that I think most people will argue with TE, because we have trust assumption, and we need to trust the chip manufacturers because they develop the whole TCB we call trust computing base. Like I said, it's some software primitives to provide you the memory isolation, the cryptographic, and the instruction protection, etc. And so basically, you need to trust this kind of software then provided by the chip manufacturer. So it is so bad? Actually, I don't think so. For example, if you think that the chip manufacturer will have some backdoor put it in their chip, and it's clearly say that our country will use the neutral weapon to destroy the Earth. I think it's really impossible technically, theoretically, and the good news is we don't need to trust the peripheral devices and hardware, also as even the code providers. So we can do the verification, and so we don't need to trust them. And here's some security analysis. I think it must be put for users who care about the security of TE, and there is very short, because if you go deep the security of TE, it is a very huge sector that worth to dive in. There are several attacks and adversaries, and we have many vulnerabilities exist before. So, but basically, if we say if a TE is safe, we basically say if the memory isolation is safe, because when you run a program inside TE, you basically need to load the program into memory to execute it. So when we execute the application, if your memory is private and actually the application is theoretically very secure, and of course there are some sophisticated attacks that can, for example, they can physically attach your device and run the TE device, run your application. Maybe they can do some side channel attack or just extract the key. You use some unknown method. Maybe try just destroy a chip or something. So to be honest, TE cannot protect this kind of attacks from the adversaries, but there's also a problem I think we can worth to mention. We think if we need to use TE as a practical method, because think about if the attacker in South Korea and in North Korea and your device is located in US, the attacker can even get a visa, So that's a reality. And so take some serious trouble is when you use AT, you first need to do the remove attestation. It's actually a verifiable launch that you can like to have some code that provided by the device itself, as a T device itself, and you can verify it if it is a Genesis TE and if it is safe enough. So basically, this is done by the TE will produce the code, and this code can be forwarded by a attestation service, and they will forward the code to Intel IIS to verify the code, and the Intel IIS service will sign the code if it verification is passed, and so the user can say, oh, okay, it's a very good T, and we can put by program in it. But the problem is the Intel IIS is centralized, hosted by Intel themselves. So is it a good way? I don't think so. So we are private, so we can be trustless. So that's why we are moving from the centralized verification, which is rely on the Intel, and we can move the verification on chain, because Intel also realize it. So they provide the DCAP is some kind of software primitives to help the cloud center to host their attestation service. So we can move this part on chain, or we can do it off chain with ZK, which will have 80% gas saving. So basically, from this diagram, here is the example. We do it with ZK0 ZK VM, and so basically, for now, we just need to run the verification inside the ZK VM off-chain, and we only rely on the PCS, which is Provision Certification Service. It's actually for now, Intel we don't need to the certificates from Intel. They just provide some collateral that help to verify the code. So it's much more trustless now. And of course, when you confirm that you have a very secure TE, and you can put anything into TE actually, because the TE itself is like a host machine that you don't need to. No matter you build your application with any other with any framework or program language, like you can put a block builder in the T, you build a decentralized MUA like Flashbox did, and you also can put a DEX to build a dark pool, and you can provide a or version virtual machine to build a computational smart contract, just like Phala did. Yeah, we are a computation smart contract platform based on TE, or even you can put an AI model into the TE to build a computational AI. That's also what we are trying. For example, integrate the GPU TE into our network to actually run the AI model, AI training, and inference inside the TE. Okay. So the another thing I think I would like to say is TE loves ZK efficiency, because we have seen some problems that exist in the ZK and FHE. For example, for ZK circuit, there may be some soundness bug. That the soundness bug means that the verification is passed, but actually the status is not correct as expected underlying. So you cannot. It's very hard to find this bug, and but we can use TE as a 2FA to mitigate this problem. Or we all know that ZK sequencer, they can't guarantee the privacy. The sequencer can say anything So basically, you use TEE, you can create a secure connection between you and the sequencer, and prove that the sequencer cannot reveal any sensitive information of users. And as for FHE, currently FHE, they have, especially FHE blockchain, they have a global shared key that used to encrypt and decrypt the FHE results computed by the FHE server. But they must use, for now, they use MPC to manage the key, for security reason. But MPC have the collusion risk. And for now, if you put an MPC into TE, you can actually treat TE as a safeguard and mitigate the collusion risk at the same time. And also, if it don't guarantee the computation validity, you cannot sure that the computation server actually did the computation as you expected. Maybe they have to do some, like, you ask them to do A plus B, they just compute A multiple B. So that's not expected. So you can put it in TE and to run it as a credential container. So basically, I think this is also like how TE and can help like the validity technology for now, and I think it's a win-win method. It's a win-win approach to integrate all the ZK and the FH together to build a multi-proof system. Yeah. So that's my share about the TE.
Awesome. Thanks, Wenfeng. I'm quite impressed by the content and by the memes, realizing that memes can tell great stories. Your memes game was spot on. But yeah, thanks for sharing that. That's awesome. And I don't know. I mean, you shared a lot of stuff, so it's maybe like we let it like brew for some time. And I think everybody that wants to maybe go back at it, they can watch the recording. One of the things that I think resonates with me, and I'll use this as a segue to then give the mic to Simone to talk about this, is maybe the identity of these devices within Deepin networks. Because if we can sort of like trust the computation, like we talked about with TE and maybe other types of technologies like ZKPs, for example, by sort of like managing the identities or trusting the identities of the devices that push data to like a certain Deepin network, I think we can achieve maybe a higher level of verifiability. And I want to use this as a segue to talk about some of the other components that the IoTeX infrastructure provides for Deepin builders, and our identity protocol that can be used together with like our verifiable computation protocol. And I let maybe Simone talk about these 9 layers of Deepin, talk a little bit about IoTeX 2.0, and then we bring it back to the specific and talk about how Phala and IoTeX work together in the off-chain verifiable computation realm. So yeah, Simone, all yours.
Actually, you mentioned a couple of things, and also great presentation, by the way, Wenfeng. You guys really, on top of TE, I'm sure, great experts. So yeah, what some observations about TE in general, and together with Deepin. TE is definitely a critical technology for any Deepin project. And the reason, as also Wenfeng mentioned, is twofold, right? One is for those Deepin projects that want to generate proof and they need more performance, right? Maybe ZK could be too slow for them, or and then they have the choice, right, to run the Deepin computation, the Deepin verifiable computation using a TE hardware. The other interesting property of TE is the privacy property. Also, Wang Fan mentioned it, right? I'm showing this slide, which is the the IoTeX contribution at a very high level of how the architecture of a DePIN project should look like. As you can see, right, DePIN projects are complicated systems. They are the combination of blockchain and IoT systems. And IoT systems are complex. Blockchain is complex. There are many layers involved in the building of a DePIN project. Not mentioning the hardware aspect, plus the identity aspects and more aspects. So the thing is that there are multiple layers, and since there are multiple layers, it's not enough anymore that you have like a single server that maybe can somehow run ZK and preserve some privacy in some way, right? You have multiple networks with permissionless nodes and in different layers. And these networks have to talk to each other, right? You need like the device generating hardware sending the device generating data, sending this data to a sequencer. And ideally this sequencer, whether it's centralized or decentralized doesn't matter, but this sequencer then have to talk to a DA, right, layer, and then the DA layer has to talk to the processing network, the data processing network, right? All these are like nodes, possibly in a permissionless network, that have to talk securely to each other. And you cannot easily preserve privacy, right? In the long term, all these nodes will have to, one, be able to identify and trust themselves using a decentralized identity mechanism, unified decentralized identity mechanism. That is, by the way, one of the DePIN modules that IoTeX provides. On the other side, if you want to preserve privacy along the all the chain, right, that the DePIN data is going through, then my opinion, you can only achieve these when all these nodes are actually being run on TEs, right? So it's not only about running off-chain computation and getting the hardware attestation of the computation. It's also about if this data come from a DePIN project that deals with private data. For example, obviously can think of health data, right? There could be many DePIN projects that could collect health data that is very valuable data, and this data can be monetized and can serve very interesting AI models, right? And this data has to be preserved. The privacy of this data has to be preserved, and the ownership of this data has to be preserved. So while this data travels from the hardware layer to the blockchain layer, it's going through all these networks, right? And doesn't matter if you run ZK on each layer, right? You also have to preserve the privacy because this layer is a decentralized network and the node is permissionless. So you have to have a secure communication, and also you have to prevent access to the data to the node operator because you are in a decentralized network. So TE seems like one solution, right, for these nodes to preserve privacy in a decentralized network that deals with users' private data. So yeah, there are many aspects of intersection between TE technology and DePIN. So yeah, I totally support these types of development, like Phala's development in this space, because these technologies are really needed, and they must be decentralized. Right? Yeah, I mean, these were just some observations I want to mention about the discussions.
Awesome. Simone, while we're at it, I think while you have this diagram as well, there was a question that maybe we wanted to get at the end, but I think it kind of fits sort of like the time now. And the question is, what does IoTeX and Phala, what is it that sets IoTeX and Phala apart from the competition, like other types of L1 and L2 network that have that provide computation like render or a cache or Golem, etc., etc. So I think we talk about that often, just as internally. We talk about that often, like at events and things publicly. So maybe if you want to share something, and then maybe I pass the ball to Zoe.
Yeah, let me actually share something very quickly about this question, because I just want to say that it's not anymore about competition of which layer 1 is better for DePIN or which computational network is better for DePIN, right? It's more about how to put everything together in a coherent architecture. So in this sense, I would say that we are very different from other projects, not really because we are better, we are also better, but joking, but because our vision goes beyond, right, just the blockchain. It's all about how can we use blockchain into real world, into physical, everyday, right, use case of the people, right? And so this blockchain is only one component of this vision, and you have to connect this component to many other components. So what is different between IoTeX and other layer ones is that we have one of the most solid and reliable layer ones in the space, but we're building more than the layer one. And if you are a DePIN project, you can save a lot of time, a lot of research that can make the difference between success or just dying, right? If you have to build the entire infrastructure. And what I think makes different Phala from others is, again, it's not about competition. It's about leading the way, right? And start building an infrastructure that is useful, and also looking at how this infrastructure can be used by as many projects as possible. I believe Phala shares our vision of being interconnected, right? So it's not only about I build the best TEE decentralized computation, right? I also find a way to make this composable with other infrastructures, so that DePIN projects or any other projects, but will also use Phala in a bigger architecture. I think that's what can be different between Phala and any other decentralized TEE network, right? It's more about mindset.
But yeah, definitely, and thank you for commenting for Phala here. But I think also the networks that Minimalist Extreme mentioned here, like Akash and so on, they don't even use TEs, right, in their DePIN. So I think what really sets Phala aside is the expertise on trusted execution environments, like from our founders and like the head of research and Wenfeng as TE evangelist, right? So we do have a very very big expertise in our team, because TE is not easy. Yeah, it's not easy to just do TE verification on CPU or even on GPU when we are expanding AI use cases. So I think this is really something that sets us aside. But however, as you said, right, it's not about the competition here anymore, especially this year where we see how important it is for Phala also as a CPU heavy cloud to bring trusted execution environment verification to GPU, right, to enable even more use cases. So we are talking with Akash and Aether and IONET and all of these other cloud providers to see how can we bring our TE expertise to actually verify also on the GPU side. Yeah, this is what I would like to add from Phala.
Yeah, totally. I give the expertise or given.
Awesome. Sweet. So yeah, that's that's actually a good point. If anybody has other questions, just feel free to drop them in the comments. I think we're almost approaching the end. I'm not sure if maybe any of you guys wanted to add something else. I mean, I know one thing, for example, that we have pending. Zoe and the Phala team had a demo that we were supposed to show today, but one of our teammates couldn't make it. So maybe there is a link that we could share, which I do have. And then, maybe Zoe can comment on just what the demo is about for anybody that wants to go and maybe check it out. And then maybe after that, I don't know if... okay, let's start with that. And then let's see where it goes. I'll share the link in the meantime. And then Zoe, maybe you want to share some thoughts on this.
Yeah, so I think, the Loom video demo that you're sharing is something that we also will publish in a bigger campaign in the next weeks. There you actually can see how we run a Llama model on H1 H100 NVIDIA hardware in trusted execution environment mode. So what does it do? We can actually verify an AI model on GPU side with TE. And this is a very big step forward regarding the TE verification and innovation on hardware side for AI use cases that Wenfeng also touched on, how you can use TE. We verify this process or the program then via the NVIDIA H100 attestation. So this is also included, and you can also verify the signatures and on the model output. So this is actually what you can see in the 2 minutes video here, and just stay tuned about our TE verification on GPU side that we will talk about much more in the upcoming weeks.
Awesome. Thanks, Zoe. Guys, I think we're almost at the end. I mean, we had set aside about 45 minutes or something like that for this. If I leave it open, so if there is anybody else that wants to maybe share something that we haven't covered, or since maybe we don't have enough time, we can maybe go for some call to actions. Maybe if people want to learn a little bit more about IoTeX and our newly launched 2.0, what they should do, and if they want to learn more about Phala, if they want to, I'm assuming maybe a good chunk of our audience today is a little bit more on the dev, a little bit more on the technical. So if they do want to build, what should they do? And maybe if they just want to learn a little bit more, what should they do? So maybe let's start with our guests. So Phala people, what should our audience do if they want to get in touch with you guys, learn more, or build?
So
yeah, I'm sharing also maybe our docs page here, which we just recently revamped. So please feel free to look over this, leave comments, contribute, and check it out. So yeah, as I said, we are going to put out a new white paper on TE verification in the next few weeks. So just follow us. We are going to host a lot of cool also online spaces and events where we will discuss trusted execution environments, similar to this space, but a bit more deep on trusted execution environments. So just stay tuned there and follow us on Twitter. Join our Discord to if you want to expand your TE knowledge. And Phala is also joining the East Global Hackathons in Q3 and Q4. So you can meet us and join to hack on Phala at East Global in Singapore, in Bangkok, and in San Francisco in the next few months. And then I hope that you see us maybe one more time on a live stream with IoTeX.
Totally. I'm enjoying having you guys over, so for sure. Wenfeng, did you want to share more, or good to go?
Yeah, we are good to go, and I'm always here for any question about TE and multi-prover.
Sweet. And actually, I'm going to share all of our X links in case maybe people want to follow and just learn a little bit more. So I'll just put them in the comments in a sec. And I see Simone is sharing some slides here, so I'll add the slides on stage. And
no, I'm not showing the slides actually.
No, okay, cool. So yeah, Simone, some call to actions for the people listening.
I think the usual ones, right? Check out the new documentation portal that is still being entirely refreshed with the IoTeX 2.0 information. docs.iotex.io. Of course, again, read. I invite everyone to read the IoTeX white paper. It's really a wealth of information and research insights about Deepin. And the developer portal, we are about to launch the new landing page in a few days, developers.iotex.io. Stay tuned. Yeah, that's all on my side.
I mean, you just drop it like that, like nonchalantly, but there is a lot, like in the few things that he said, there is a lot of information. So white paper is quite awesome. We went through the docs as well, and the new docs that reflect the 2.0 vision coming together, and the dev portal as well. One thing actually for the dev portal, if you guys go to developers.iotex.io, you could actually subscribe to our newsletter which I think it's a good way of keeping up with our developer community, and we always add news about what's new in IoTeX, what you can build, new examples, guides, etc., etc. The docs are docs.iotex.io. I think I shared them at the beginning. Yes, I'll pull them up here again. And if you go to IoTeX.io/2.0, there is like an intro video that's basically like an IoTeX Deepin primer from our team, myself included. And then there is also the link to the white paper, which is pretty cool. And if you want to keep in touch with all of us here up here on stage today, I just put some of our X handles here. Other than that, I think we covered. Yeah, go for it, Zoe.
Very quickly to promote DePIN Scan. Really, you shared the link in the beginning, and we touched on this. But DePIN Scan is really a cool explorer for everyone who wants to learn about different DePIN projects. Right, it's really cool to get an insight, like who is building DePINs and so on. Even if you want to invest in some of their projects and so on. So a product that I really love to use myself personally. That's why I have to promote it here once again.
Thank you. That's nice. Yeah, I agree, and not just because I'm part of the IoTeX team, but it's something that we launched as like a public good. It's like completely free. Anybody can use it. It's just a way to like keep up with the whole ecosystem. And yeah, we put a bunch of resources in it, but it's for everybody in the space. So I'm glad you guys are enjoying it. And maybe we close with this comment from Peter that says, very technical. It would be good to have a grandma's version. So I guess we need to come for episode 2 of this and make it the DePIN verification for grandmas and grandpas. And and see where that goes. And if we do, Peter, that will be thanks to you. So thanks for the input. All right, guys. Thank you so much. I hope you enjoyed. I see you around on various socials, telegrams, maybe around the world, wherever we are. We have some events coming up, but we'll share that soon enough. And see you guys around.
Bye, guys.
Yes.
Thank you.
Thanks for having me.
Bye.
Bye.